Welcome to Unreal Engine sample project. My name is Cliff, and in this video, I will go through implementation of interface with Unreal Engine by using C++. So we use a sample project like previous video, which I go through interface implementation with Blueprint. We will use a sample project to explain and practice the topic. And we will learn how to make interface with C++ with Unreal Engine. You need to have intermediate skills of C++ programming with Unreal Engine. You already need to know how to make events and understand parent classes in Blueprint and C++. And basic knowledge of Blueprint interface implementation is required. So if we, perhaps you may need to check the previous video, which is about interface with Blueprint, and then back to this one. By end of this video, you will be able to implement C++ interfaces by using C++ to implement Blueprint implementable interface and pure interface by using C++, two different stories. And you will learn how to send and receive data between objects. Please make sure you download the sample project in GitHub, run the project. Well, it takes time to, compile shaders, make Visual Studio project file, run the project, make sure the Visual Studio is working fine, no problem. It's Unreal Engine 5.6. And in this video, we check the sample project and review Blueprint interface and compare that to C++ implementable Blueprint interface. And then we use line trace in C++ to run our interface from C++. Previously, you will learn how to run interface by line trace in Blueprint. This time, we use line trace in C++ and run interface by using C++. And we will go through access objects by using parent class. At the end, there is a homework. Let's say practice something like this to just make everything fine. Alrighty, so let's begin. So after you run the project, you will have something like this, and excuse me, it's very important that you run the project, you make sure the Visual Studio is everything is fine. You don't need to wait until it just do compiling or just change. Everything goes perfect. Perhaps just check if you can compile. For example, I add a space here. Make sure you, let me just move myself. Make sure you just untick the enable live coding. Compile, check output, no problem, perfect, and clear log. Here we go. So what we have here, which is, let me find the project. Excuse me. So what we have here is very simple, very low size third person template, C++ 5.6. I use third person mannequin just to reduce the size of the project. The project is exactly same as the previous video project, which is Blueprint interface, this guy here. Just run it, perhaps just download and run that one as well. So this is exactly same project, same object, and the same interfaces. But here I have Blueprint interface. Here I have a Blueprint interface, which I don't use. And I have here, if we go to C++ classes, if you click on public, I have a C++ interface. And the interfaces are exact same name as blueprint. Activation, check key, and if you check the other project, here we go. Um, Activation and check key. Where's check key and activation? So, well, you may surprise Cliff, what is that breakfast here? Basically, this is the interface I made in that video, and I just stays here anyway. Funny. But yeah, the projects are exactly same, but in this project, the implementation went through C++. Okay, let's see what we have. If I press play and I press E, I can activate and deactivate this switch, or let's say gate, whatever. I have key number 8, and this one accept key number 8, as you see here. So if I press E, I can activate and deactivate this one as well. I can't do that with this one because it required key number 4. Perfect. I can press Q, grab the key from here, and activate this one. So refer to blueprint interface implementation. Let me open the third person character here. Here we go. Refer to blueprint implementation, which was in this character in the previous video. Every time you want to run an interface on blueprint, you grab the other actor. From the other actor, you figure it out if that interface exists. Does that object implement interface, yes or no? And then you can call your interface functions and events. That's how Blueprint was working, is working. In case of C++, it's exactly the same. This is my Blueprint implementation, BPI activation check, BPI activation receive. I send message, I send ID. So if, and here is the C++ implementation. I have CPPI activation check, CPPI activation receive, key ID message, same. And when I try to check if that interface exists, exactly like Blueprint BPI, which shows me a list of Blueprint interfaces, I can say CPPI. So CPPI is my naming convention, Cliff naming convention. Perhaps you comes up with a different one, I underscore or ICPP underscore something. But again, like Blueprint, you need to be organized, you need to be professional. It's an industry practice that you name your interfaces with something you can easy search and easy find. So in my case, in my area, I prefer to use CPPI for C++ interfaces and BPI for blueprint interfaces. And here we go. If I type CPPI, I have activation check key, an example, and an item tools. Perfect. So, but something is interesting. So if I have blueprint interface, I can double click. I have a luxury of add function name, easy add variable. For example, if I add a new interface, let's call it BPI underscore KO. I use KO because that's easy to find. Nothing in engine is called KO. And every gamer knows what KO means anyway. And I can easily add my variables, compile and save. Here in third person, straight away I can call KO. And here we go. I have my interface up and running. No problem. On destination, though, on the receiver, which is these objects, I can go to the interface section and I have my blueprint interface ready to go. So in blueprint, it's pretty simple, pretty straightforward. No problem. But when we talk about C++ interface, there are two different stories. So sometimes you make an interface with C++ which you need to use in Blueprint. What I mean by that, that means I have a third person character and I can call, where is it, character one? I have my character, which is this character of the game, Rose, this guy. Sometimes I want to call my C++ interfaces which made in C++ in Blueprint, which is like this. I have the luxury of call them like this way, CPPI, and I have a list of interfaces which I made in C++ in Blueprint, like exactly the way the Blueprint is working. If I type BPI, I have my Blueprint functions and events of the interface, including this one, which I recently made. So this type of interface which you made in C++, these guys, are called C++ Blueprint Implementable Interface. Huge name, I know it's a long name, it's just hard anyway. But yes, they called C++ Blueprint Implementable Interface. And what they do is basically you have a luxury to call them in Blueprint like this, but if you double click, you don't have the option to edit them like what you have with pure Blueprint interface. All right, that's the difference between these two. And there is another type of C++ interface, which is basically this guy here. This C++ interface, which is item tools, I will go through how you make it, how you implement interface, all these things I will go through in depth. Just grab the pattern, grab the frame first, and then we'll go through details of implementation. All right? There are some other C++ interface which you don't have access in Blueprint to them. For example, here I have CPPI item interface support. So if I copy this name and back to the Blueprint, and then I try to call this interface on an actor like this, it doesn't give me any name. So this type of C++ interfaces are not approachable in Blueprint by default. You may find a method or something to make them visible in Blueprint. I'm not going through that far, all right? By default, you can see them. Only C++ can access them. Only C++ can run them. So let's say these are pure C++ interface. All right. So far we have pure Blueprint interface, of which are these guys here. You can right click, go to Blueprint, Blueprint interface. You made them. BPI underscore is my naming convention. Is up to you. Having a naming convention is an industry practice. Very important. You must, as a programmer, do it. Believe me, when you go for job interview, when you apply for a job, when they check your code, these things is important. And believe me, that makes your code very much organized when you use and work with interfaces. And here we go. I have Blueprint interface. I have a luxury to edit. Let me just minimize this guy here, moving on top. And you can add variable input and output to your Blueprint interface, no problem. In case of C++, though, you have two types. One is C++ implementable Blueprint interface, which you can access in Blueprint, use it in Blueprint, assign it to the objects in Blueprint. Here we go. And there is another one which is pure C++. Okay, let's dig in more and see how we make it. So to assign a C++ blueprint implementable interface, you need to go to class setting, go to add, and here we go. When you type BPI, like before, you can add blueprint interface. If you type CPPI, you can add C++ interface. Perfect. Awesome. So here I just add CPPI activation to this guy here, which is this object and this objects. And for the key, I just add a CPPI key interface check key. Exactly same like the blueprint one, but this one is implemented in C++. How the object works with these interfaces, with C++ interfaces, let's just open switch 00, same like blueprint. Here we go. You have the same icon on events. This is the interface icon. Here's my blueprint one. I disable it. I just use the C++ one and it does the job. Same like this one. And if you go to switch number one, first, here we go. Same switch number one, sorry. Here we go, same story. I have a message, I grab the name, I grab the ID, compare that to my own ID, and then swap the gate, open that gate. I didn't use the blueprint one, I used the C++ one. Perfect. So that's how you call and use them. And in case of key, same story, class setting, C++ check key. If you open the interface, because I have Blueprint and C++ together, I have two sets of interfaces. Well, the C++ I have one more, which I will go through. But same story. This is key ID in C++. I send ID. This is the Blueprint one. Exact same. I send key ID. And the other one. For here, I just print out some messages. So the implementation is exactly the same. All you need to do is make it in C++. And then in Blueprint, you have access to use it, implement it, assign functions to the object with that C++ interface. To call it, same like Blueprint, same story, same icon, having naming convention again is extremely important. See if when I type CPPI, I have all those interfaces. Check key CPPI, these are my method and functions. Check key CPPI, these are my method and functions for that interface. Perfect. All right. Now the question is, perfect, we can do this, how we can make it, how we can make this CPPI interface. So you need to go to Tools, New C++ class, go at the end of this list, you have Unreal Interface, next. So naming convention, as I mentioned, CPPI is mine. I prefer to call it CPPI. Perhaps you call it IPPI or perhaps you call it I underscore whatever. I don't know. But having a naming convention is important. Underscore name of your interface. So I made my activation, and after you made it, the engine will gives you something like this. You have U interface, a minimal API, and then you have class, CPPI activation, whatever name you have, the engine automatically will add an I before it, and public, and there is nothing here. And here you can put your interfaces, which I will go through in short. This part it has its own story. It's just funny. Anyway, um, and that's how you make Unreal interface. And then when you go to Blueprint, you have access and you can call it from the actors. Here we go. this guy, CPPI, there. Now, to understand blueprint implementable interface, the develop, which you make by C++, there is an object here, BPCPP, interface example. This object is using CPPI example, C++ blueprint implementable interface, which is this guy here. I didn't use any naming convention for naming this interface because of a purpose. So if you open interface section, you will find C++ interface void, C++ interface with return. And I just named them this way just to give you an example of how different you can make this, you can develop this interface. You may find some tools or forums, perhaps they use this method and this method. Some other forums perhaps use this one and this one, and you may get confused. Okay, Cliff, which one is right? Which one is wrong? What is the problem? What problems may happen when you try to make the C++ blueprint implementable interface? Jesus, that name is quite long. um, so this object is just an example. Please do not follow the naming convention which is in this example. The right naming convention is using CPPI or I underscore or something like that. This is the right way of naming your interface. In this object, this is just for academic purposes to show you how things can be implemented in many different ways. So let's begin. This one is a job, actually. So I made ICPPI, I made a CPPI underscore example interface with C++. How I made that, I just go to Tools, New C++ class, all the way down, Interface, Next, and I call it CPPI, CPPI underscore, and the example. And when I press create class, it gives me this guy. All right. I have two series of interface here. The first series are made by a void U function. As I mentioned, you need to know intermediate level of C++ programming with Unreal Engine. If you don't, please review them back here. Anyway, this series of interfaces are void functions. The other ones have a return value, two different stories. Okay, so let's see what is going on. I have a blueprint callable blueprint native event of U function, and I just send an integer. I just put an integer parameter called ID. And when I go to blueprint, I see I have this interface void one, which is this guy. So every time from C++, which you will see how to, be patient, every time from C++ I call this, or from blueprint I call this, I can send an ID, like blueprint example. So if I go to switch phone, like this guy here, here I send message to. So how you make it is, one method is this way. You can say it is a blueprint implementable event, and I send a constant data type reference, and I call it, for example, here I send a string and I have a string and I call it password. And if you compile it, you will have something like this. All right. Now, if by any chance you say Let's just comment this and uncomment these lines like this. You forget to make it a constant. You forget to make it a reference. You just say, okay, that's integer ID, no problem. I send an F string, and I call it, for example, ID. Not ID, actually, ID is wrong. My bad. Sorry, it should be password. Here we go. So let's compile and see what problem just comes up. As I mentioned, this sample project is just a practical sample project for you to experience, check the code, change it, see the problems, and learn how to make it right. So here we go. Interface, target, potentially compiler. So as you see, it doesn't like it very exactly mentioned here. Error, overload member function not found. So it's good if you know these error messages. Sometimes you will get hired to work on other programmers and perhaps there are error messages. So knowing these error messages will help you to figure it out. Okay, perhaps we have an interface problem. And you check the interface code and see perhaps the problem is there, for example. So knowing these error messages is useful. All right, perfect. This doesn't work. Or you may have this problem. So I may say, hey, here I do constant. I don't send a reference. So let's just compile. And I have problem again. Here we go. Not found in example. So keep in mind, C++ of Unreal Engine, as you know, is very sensitive. When you do interface programming, you need to be very careful, perhaps double careful, because you may end up with error messages which totally unknown or cause a lot of problem. Anyway, so how about this one? I have a constant string reference, and that is my parameter name, password. So I have a constant reference of a string. I have a constant reference of integer and ID pass. So as you see here, sounds like I use a constant integer reference instead of using integer ID. How that works? I need to compile to remove that error message before. Perfect. So here we go. And that one is basically this one. Number 3 and number 3. So when you have a class structure in Unreal Engine, as far as I know, it's better you send a constant reference of it, like if a string. But in case of integer, things are different. It can be a constant reference, or it can be normally like this. Keep in mind, I'm using void functions. I didn't move to return part yet. So now let's say, all right, I have integer reference ID. How about this one? How this one works? So if you check the code, it's basically this one, and that is a function. So that if you use integer reference and ID, I put that here as well, using void with this, basically you make an interface function and you return that ID, that basically data type as a reference with that function. Interesting. How about the last one? Um, let's just check one problem here. So imagine instead of this implementation, I made it like this. I made a constant integer reference, an ID. and that's a void. So how about this one though? That one should change things, I guess. Let's see. Yeah. Mhm. Go to object. Don't forget to compile. And here we go. As you see, the interface is changes to this one here. Number V. Go to the number three. Was it number three? Let me just double check. I have V01. Yes, that's true. So it's this one. Yeah. So basically, it just gives you the same as this guy here, as this guy here. No change. It's just a constant reference of something, and that's a return value. So when you remove that constantness of it, you will send a reference of it as a function to the rest of the object which that use that interface. Let me just compile again to remove those functions. Here we go. So, by the way, when you work with interfaces, let me compile. Unreal automatically remove the interfaces which you remove from C++. See, I just comment out this one, and basically it doesn't get compiled. In Blueprint, though, the Unreal automatically will change that interface to an event. So it will be part of your events. You can get rid of it, delete it, no problem, compile and save. Nothing goes wrong. Or perhaps you can use it for debugging or commenting or something. It's up to you. Same with functions. It will change that to a blueprint function. So nothing will break. Everything will be fine. So, and the last one is a void. I will send, I will, actually, I will receive, let's say, a name and an ID as an integer and string, and I will pass um, an F string as a password and an integer as an ID. So when you go to the implementation, you will find this guy here. I receive a password and I send the name and ID. Name and ID. So these are void implementation of interface, blueprint implementable interface in C++. I prefer to use void functions because they're straightforward and handy. There is another method to implement interface functions. So with void, you can make events and functions, but with return value, you can make functions. And as you see here, if I go to interface, all the interface with return value, all of them are basically functions. So you may find this in some tools and you may surprise, okay, what is the difference? So this basically, this example interface, I try to cover all of them as far as I can. And just to give you an example of how you can program them. Perhaps you find other programmers use different methods. You may find that here, you may practice that here and just implement on your main code. So let's quickly go through this part. I have interface return value type A and type B. And as you see, I just return an integer. I don't have any input here. So if I go to a blueprint implementation, type A and type B. No change, exactly same, no problem, all good, same, same. But let me just change that type A to something different and see what we have. So if I say, oh, my bad, sorry, sorry, my bad. Here we go, type A, type B. No, so the only difference here is we have an integer return value with blueprint implementable event. Just interesting. Unreal Engine is just C++ in interesting. And the other one is blueprint native event. Both of these implementation will gives you same function. This guy and this guy. Even sometimes I just freak out, okay, what was what? But yeah, that is the point. So it doesn't matter if you return something, you make it implementable event or native event. Now, if I return a constant integer and I have implementable event and native event, what is happening? So if I go here, go for type C, same story, no problem, no drama. So you may find some tools use this one, you may find some tools use this one. Now, if I say I send a constant of a string with this guy here, so we can guess that we should have a return type of a string. Keep in mind, this guy is a return type, but when I have the void one, I can name my passing parameter title. I can name that parameter in a way I like. This is why I prefer personally void interfaces. But when you return something, you have a return value. You can change that to return value by default. I mean that name of title of return value by default to the data type or anything you want. Anyway, interesting. Now let's see parameters. I return integer. I am blueprint implementable event, and I have a parameter of a reference of a string called password. So if I go to type A, as you see, I return an integer and I also return a password. Now, if I change it to this, so instead of having a reference, I just send a f string password. If I compile this, the engine doesn't like it. So he will have error message. So let's check what we have here. This guy. Overload member function not found in that interface. Same error message actually. So be careful. You need to don't forget that reference if you use a class like f string and structure like f string things that class actually. Um, Let me just compile and fix this problem. Perfect. All right. Now, for the type B, I have a constant reference of my f string. For the type C, I have a constant reference of that f string. I have a constant reference of an integer. I have a reference of a string and I have a reference of integer. Keep in mind I'm returning integer as well. So if I check type B and C, I receive a password, and for the type C, I receive a password and ID. I return that integer in both of them. As you see, the return type is there. But for the second one, I receive pass basically name and ID. Very similar to this guy here. But in this case, I have a return value because I am returning an integer. And well, blueprint implementable event, blueprint native event, no problem. For this one, I return a constant of a string. I pass a password, I pass an ID, I receive a name, and I receive an ID. And here we go. For the D, here we go. This is the string of a constant of a string return, and these are the rest of them. Very useful link. Don't miss these links here for C++. And well, that's as far as I know with Blueprint implementable interface um, in the implementation in C++. Let's say that's quite long. But well, hopefully that helps. That gives you different situation of implementing that interface. But keep in mind, do not name your interface like this. This is just for academic purposes, just to show you how things are different. Use right naming convention, BPI for Blueprint, CPPI for um, C++ based interfaces. Alrighty. So with this basically quite huge introduction to the topic, let's check my interface. I have an activation check. I have an activation receive, constant if string message, constant integer ID. So if I go to this key number 01 and I check my interfaces, you will find actually not key switch 01, my bad. Here we go. And every time I call activation receive, this guy here, I will I will activate an event which gives me a message and an ID. Here we go. Very important. Let me just bring myself at the center of attention because this is important. Very, very important. When you try to use interface, doesn't matter, Blueprint, C++, Blueprint implementable interface, or C++ pure, it doesn't matter. The object you try to communicate must have an interface. Always. Why? Because from the heat actor, from the other object, you will try to know, okay, is that interface exist or not? And then you can run functions and events. All right? The object who called the interface, this object doesn't need to have that interface at all. You don't need to have that. So the third person character, if I go to the class setting, oh, here we go. I don't have those interfaces. No C++, no Blueprint, nothing. I don't need to have those interfaces. None of my business. All right? So don't freak out. Don't put interface of both object. You know, if you call an object, those need to understand what you are calling. So they need to have that interface. If they call you, so you need to have that interface to answer them. So you need to have that interface. In this example, I never get called by any object. Every time I run the game, I just calling line trace, another line trace, and that is my communication between these objects. This one doesn't work. That's perhaps is your homework anyway. But yeah, so just for the last time, every time you want to use interface, you want to use functionality, you want to implement functionality by using interface on any object, that object need to have that interface. If you want to call that object from anyone, anywhere, the caller doesn't need to have that interface. It just need to check if that interface exists or not, and then do the job. That's it. All right. So don't freak out. This is something I see some students just totally didn't get it and end up with a lot of interface implementation, which is totally unnecessary. So yeah. Okay. Nice. So what else we have here? I have my key interface. It has get key, it has check and get key. Let's check the get key as well. And here I have my key. As you see, I have here I grab the player name and I send the ID. Here I just send the ID. And there is another one which I grab player, I grab the active. I use these data, change these data. For this one, I just print out. For this one, I just inverse it and send it back from here. I send a message, send an ID. Perhaps I have a lot of code to do here. Doesn't matter. Keep in mind, if you use an int, let me actually just let me show you. This one is interesting to know. So I made another object, duplicate my previous object. In this object, I just change it. This is a different key with different code. Change the color as well. I mean, this is obvious, but sometimes you may just think perhaps something is different in this area. You may surprise, okay, what's going on? Just one moment. Perfect. So I have another key. Compile and save. Imagine this key is different, has different code, particle system, sound, everything, totally a different object, which is a different object because it is a copy and change of key one. And I put this one here. All right. Because it has same functionality, I can have same key and all those things. If I run it, if I grab it, I will grab key number 4. From here, I will grab key number 4 as well. So if I change this one to like key number 10, it has exact same functionality with same interface. This one gives me key number 10. This one gives me key number 4. Perfect. So if I use interface on this one, and I use exact same interface on a different object, it doesn't matter what type of code you use inside your interface functions. So in this option, in this in this one, perhaps I want to send ID, for example, 10,024. And my message is, for example, red. For the key one, I will say orange receive because this one is basically an orange color. All right, compile and save. Let's run this interface on these two objects and see what we have. So if I go to my third person character, here we go. Every time I press Q, where is my Q key? Here we go. Perfect. Every time I press Q key, also run, example, was it CPPI, example, check key, multiple value, example message. Here we go, this one. So I call it, and let's see what we receive. Right? And I have an ID, and then this guy. Oops, my bad, sorry. And then this guy. And then let's have on the last line, I have the I have the messages. There we go. Perfect. Like this, compile and save. Let's see what we have. So as you see, here, if I press Q, I have this message, 1024 true, red, and here I have another message, 74 true, orange. So it totally, the interface on objects run totally independent. You have specific code here for the similar interface. You have another type of code for the similar interface. These two objects can run different things. Excuse me. So this is very important about interface and makes them extremely powerful and useful. Alrighty. We know how to make blueprint implementable interface by C++. No problem. What about pure C++ interface, which is this guy's here? So if you want to implement the pure C++ interface, you have three main approaches. The first approach is basically you send everything you want, every data you want with one interface. So here I have CPPI item underscore interface support, and I will send everything by this one. Or you group them. You say I have activation, the activation with furlough and enum. The enum activation on top is activate and disable. This is my activation. And for the rest, I have a setup and everything else I will send with this interface. Or you implement one interface for each piece of data. This approach is quite useful when you want to run interface on tick. So imagine every tick you need to send all these things and you only need to use this one on tick. Not a bright practice, too much load for engine in the background. Not good. Perhaps you send your data by this one, activate with ID, and this one is the only thing that tick need to check. That's great, very nice, one interface. And in animation programming, AI programming, sometimes you really need speed. Things need to be happen fast on interface. When I say on interface, I mean you don't mind what is the other actor. You run the interface, and if that actor has that interface, then everything will get executed. So these three approach are mostly used um, in blueprint interface programming or C++ implementable blueprint interface implementation. You can follow this approach, but mostly in pure C++, things are very important. You can reach to very good optimization, speed, and visibility of your code if you use these approaches in the right location. For example, when you load when you load something from user interface, perhaps this is useful because that happened just once and there is a loading screen. Everything happens in the background. Perhaps this is nice. And perhaps in some cases, you use this one on tick and use the rest on something else. So it's up to you. All right. So this pure C++ interface doesn't have any blueprint macro at the beginning. So when you want to make it an in C++ interface implementable in blueprint, you need to use macros like this. If you want to make C++ pure interface, you don't need to use those macros. You just make a virtual class. Some can return value, some can be void. Then you need to go to CPP file, implement a source file, a body for that function. Basically, these are functions. Same naming convention, everything. Perhaps return something for this one if you have return value. In case of in case of blueprint implementable interface, you don't need to put those things by default in CPP file, but in case of C++, you need to. And by any chance, if you are using an abstract class, which is this guy here, the abstract class doesn't need to get implemented in CPP file. All right, you don't need to implement that here. And if you do, there will be a compiler error. Actually, let me just, well, if I compile this, there are other compiler error, but we will back to this part soon. If you have an abstract class, this abstract class must be implemented in child classes. I will back to this part again. So now there is a main question. Perfect. We run interface, blueprint implementable interface through blueprint. Very well, very nice. These guys here, grab E and Q, and I run this interface. How about C++? How we run C++ blueprint implementable interface from C++. How we run pure C++ interface from C++. Well, you can't run pure C++ interface from Blueprint. It's on your hand as a C++ programmer with Unreal Engine. No access from Blueprint by default. I mean, direct access by default, which sometimes feels good, to be honest. Anyway, so to demonstrate how C++ can run C++ implemented interfaces, I put my line trace totally into C++. So instead of running the line trace from Blueprint, I just run it from C++. So let me move this E key as well. Here we go. And that's it. So there is actor component called tracer. This actor component is responsible to give me a couple of functions. Excuse me. These functions are responsible to run line trace. For the first one, I grab a result and I have a return value. And that return value is basically an actor. From that actor, I can run my C++ implementable blueprint. No problem, very easy. I just simplify this part and this basically return. Now let's check the code actually. Let me just minimize this guy here and go to the code of tracer. Here is my actor component. I have type A, which returns an actor. I have type B, C, D, which are void functions. And from each function, from type A, I just run a line trace. Grab the result of line trace if that hits something. This is a Boolean. I have a reference Boolean parameter, which basically comes up as a return value. And I just return hit actor as well. So keep in mind, as I mentioned, you need to know C++ programming of Unreal Engine before you come to this video. Let me just point out to this one. As you see, I am returning an actor, and at the same time, looks like I'm returning another value as a result. So every time you have a reference parameter, basically in Unreal Engine, it will get returned as a return type, as part of the return type of that function, which will comes up like this. Quite useful, quite handy. And then I just run my interface, whatever. So if I grab this one and use this one here. So in type B, everything is happen inside C++. I'm sending name and ID. Here, as you see, I'm sending name and ID to blueprint implementable. Here, I do that exactly to same interfaces, but totally everything going through C++. Let's check this one, which is basically this guy here. I did not return anything. So if I go here, there we go. So Let me just increase the size of this guy here. Very important, extremely important thing you need to know. So sometimes you get hired for the office, game programming, application programming, Unreal Engine, and you make your own interface. No problem. You know the engine version 5.6, 5.7, 5.2, 5.5, whatever. You make the interface, you program the interface, no problem. Sometimes they ask you to upgrade an old application, Unreal Engine 4.27, Unreal Engine 5.0, 5.1, to a latest version, 5.6, 5.7, perhaps 5.8 right now. I'm not sure. Anyway, every time you try to upgrade interfaces from old version to new version, you must check documentation of Epic Games related to that version. Sometimes there are things which are changed and you need to know about it. So this part is an example. Heavily recommended if you try to access Blueprint implementable interface in C++, which made in C++ from C++, check the latest documentation of the engine and then start work. All right. So this is very important. You will save a lot of time and confusion if you first check the engine and the C++ implementation, see how that is working. Is that changed or not? All right, here, let's put this guy here back. And so to call an interface, Blueprint implementable interface in C++, first thing first, what you need to do, you need to, well, in this case, from my line trace, let me back to Blueprint. So as you see, from the line trace in Blueprint, I grab the actor. From that actor, I check the interface, CPPI activation. If I would like to do that in C++, you need to call the interface. This interface need to get included to your class. So I have a reference of that interface. From that reference, I call execute the method of that interface. So if I say column, execute, here we go, CPPI activation K, check, hide, receive. If I go to that interface, which is my activation, CPPI activation, header file, check, receive, hide. So the engine automatically will, the Visual Studio automatically will show you the events and functions of that interface, which you can access and execute. That execute keyword is important. So, how you do that? You need to grab the actor from the actor get class, and then you need to call implement interface, U CPPI activation. Keep in mind, you need to put U here. When you try to execute, you need to put I here. One of those things, anyway. So very important. That implement interface is basically in Blueprint works like this guy here. You check if that interfaces exist, and if that interfaces exist, which is that if statement, if that returns not null, that means that interface exists, then it can call that interface and do the job from the static class. Perhaps there are other methods to do this, but please put comments, show more, share your opinion about this part. Perhaps you know some better method or other methods. Good to know. Anyway, so for the execute activation check, you need to, if I move on this guy here, you see you need to send a U object. And that U object is basically your heat actor. And that heat actor is basically the object who owns that interface. this guy here. So this need to be sent with 5.6, Unreal Engine 5.6. And then you can send other parameters like this way. So here I send name and ID. I already received that name and ID. And I send it through activation receive. So if I open this guy here, that activation receive is this guy. I send name, message, and ID. This is blueprint, but in case of C++, yes, that's actually that's happening. Yeah, that is my. Let me double check. Yes, that's true. Here is my message and ID, and here is my message and so from C++, yeah, I will directly call this guy. I figured out this actor is the output of my line trace. This actor has this interface and send this data. Now, the question is perfect. How we receive data? How about the other one? So if I run the project, here I have, if I go to character, first go to the character. From here, I grab this Q and there we go. I am running tracer type, trace type C on my tracer and I receive data. I send a name and I receive data. Exactly same like this situation. I send my name and I receive the ID. If I run it, here we go. I grab number 4. Oops, why? Because, the player name. Oh my God, yes. Here we go. The player name is player A, and this guy, player name is player A. Why it doesn't should accept? Why it doesn't like me? No, something is broken. Here we go. Now I get it. Okay, no problem. There. Q number 4. Perfect. Well, sometimes you need to double run the application when you work with C++ interface and you compile and recompile the project. Sometimes that happens. Just good, actually, that happens. You see the problem. Anyway, so how this part is working. So first thing first, I have let's check the C++ interface. Yes, I am sending player name. I have an activate and I receive an ID and I have, oh, sorry, my bad. I send a player name and I have an ID, return an ID, and that is my check and get ID. If I run it through Blueprint, if I call it through Blueprint, I have this part here. I send a player name, I have an ID. Here we go, player name, an ID. Awesome. How I do that in C++. So if I go to my tracer, here we go. Same story, implement interface, static class. Is that interface exists? UCPPI? Yes, that is exists. That if return true. And then CPPI check key. Don't forget that. Execute. That is sending call function. And I send this value. And here I send and receive. So whatever this send back to me will get automatically saved in this variable. I send it to -1. Here, if if that interface exists, it will get charged. It will get, it will received. It will get loaded with the data, integer data, which is number 4. And that does the job. Now, you may surprise how we call that interface, which has multiple. I send player name, I have bool, I receive ID, I receive his damage, I receive a message as well. This guy here, how we call this one in C++. Let me just go to switch number 1, and that is this guy here. Oh, sorry, my bad, switch number 2. wait, which number? Oh, sorry, I just put that in the key there. How we call this one in C++? Blueprint, no problem. We can call simply by just call it like this way. Where is it? Here we go. I can call it in blueprint by this. How we call this in C++? So I have a player, an action which I send, and I have ID, is damaged, and message which I receive. So here we go. I can execute that interface. I send, see the order, I send the order, and then I receive and receive and receive. Very important. This order and data type must be accurate. Otherwise, you will end up with problems. So first one is a f-string message. Here we go. Let me go to the key implementation. First one is an f-string data type. The second one is bool. The other one is integer. Then I have a bool. Then I have a f-string. So the first two are send. These two are received. When I go to the CPP, as you see here, sending, sending, receive is a variable. Whatever I get received goes to this variable. Receive is a variable, Boolean variable, same data type, same order. And receive is a variable again. Whatever I receive, I will save it here. And there we go. I have the result. So if I run this, and as you know, it automatically will run that in the background. Let's go to the log, run the game, and let me just say Q. Here we go, 1024, no damage, read received. This is running from C++. And if I run this one on this guy, multiple data, 74, no damage, orange received. And this is running totally in C++. Awesome. Nice. Perfect. So, with this introduction, not introduction actually, with this um, part, we can switch to pure C++ interface and how we call them. By the way, same story we have for hiding objects. Excuse me. I grab all actors who has a CPP interface, save them in an actor container, and then just call that interface on all of them. And if they have a hiding, if they have that interface, which they have actually, if they have that hide implemented, that hide get activated and do the job on each of them. For some hiding can be resizing, for some hiding can be changing visibility, for some hiding can be totally change location to minus Z 10,000. No one can see them anymore. Something like that. So each object may run different hiding strategy, but all of them can get called through an actor container with one interface. And that is the magic of interface programming. I saved a lot of memory. I didn't put anyone. I didn't make um, reference of each object, and from that reference I try to run some interface of. No, I totally run everything through a parent class. So how we can run pure C++ interface on objects? So as I mentioned, this part is totally can be implemented in C++. You cannot run pure C++ interface from Blueprint. You don't have any access to them. Only C++ programmers can run, only C++ programmer can make it. They can expose the result with Blueprint events, but direct access by default is not possible. So let me open map number 2. Oh, not save one. All right, here we go. So here we have same scenario as we had before in Blueprint sample project, previous project, sorry. But I can't activate this guy. This guy totally doesn't work. And even this guy doesn't work. Even if I press Q, it doesn't work. Only I should press T. Oh, sorry, I should press F, and it does the job. But this one is your homework to make it functional. But for this one, sounds like that F button, which as you see, totally run type D, which is another trace type D, which is a C++ function in my tracer. It sounds like that thing is totally is in C++, and this object is totally work with that in C++. The other objects too are working with Blueprint. Same scenario, but these guys are, I need to press F to turn them on. If I press E or Q, they don't work. Same scenario, same story. Let's just finish it. I need key number 4. Just open this guy, open this guy. Oops. Ah, I have key -1. Why I have key -1? Oh, because I grabbed the key from this object. Yes, I need to grab key first, key 8. Anyway, so um, what's going on in this object? Well, how this is possible? So to use pure C++ interface, first you need to apply that to inherit that to a parent class. In this example, I have my BP gate. This is a blueprint actor. So I need to make an actor in C++, which is this guy here. I inherited the interface item tools, which is this interface, pure C++ interface here. Okay. And then from Blueprint, I need to, if I open this Blueprint, go to Browse, go to class setting. From Blueprint, I need to, item 01, I need to inherit this Blueprint actor to C++, reparent this Blueprint actor to C++ actor. So, this is something you need to do before you using the interface. After you do that, so here in my example, I have an activate item in Blueprint implementable event. I have Blueprint implementable check item. I receive a message of a string. As I mentioned, you need to know how to implement events in C++. This is requirement of this course. Just review. If you don't, here I have another event which I receive an ID, and here I have another event which I receive basically a Boolean. And I have item hidden, activate with data, activate with ID, and CPP item get ID. These are basically the interfaces which I inherited from this item tool. And as you see, all of them are virtual. Perfect. Keep in mind, if you have an abstract method, oh, sorry, my bad. One moment. Item tool H. Here we go. Item tool H. Yep. So yeah, that I'm fine. So if I have an abstract class like this, you must implement the abstract class when you inherit it in any object. If you don't, you will have a famous message. Let me show you the error message actually. Important. So what is happening? I have an abstract method in my interface. Abstract method are functions or methods which are equal to 0. In other language, they don't have any source implementation in CPP, any body implementation in CPP file. Okay, that's pure C++. So if I made one of them, and then I inherited that interface in an object like this, and I don't bring the signature and implement that, I will have this error message. Let me just run it, compile, compile it, sorry. And here we go. And it is a very famous message. Cannot instantiate abstract class. So keep in mind that is important. This error message mostly points out to the abstract class problem. To fix it, you need to implement that abstract class in your objects, which you inherited that interface. In this case, I just make it and then I move to my CPP file and then I just implement it like this. And then if I compile, problem will be solved. Perfect. All right, so be careful, abstract classes are. And the reason you may have abstract classes is back to how you plan to make your pure C++ interfaces. Mostly programmers put abstract classes to just make sure that the other programmers who use that interface always implement this method. So perhaps that's a very important method because of the game scenario must be implemented. You make it abstract. Every time anyone uses this interface, he or she will understand exactly this need to be done in the child class. All right. And then what? Okay, I have my interfaces here, and you need to implement functionality for those interface. Depends on your code, exactly like Blueprint, which you have interface, you have functions. Inside the functions, you do the job. Let me just show you one more time. Here we go. I have in key 01, this is my interface function. Inside this function, I have things to do, or anytime I call that interface, I need to do a couple of things. Where is it? Here we go. Switch number 1. Here is like a interface event. I just called it and it does the job. When we go to pure C++ interfaces, you don't have that Blueprint luxury to grab it in Blueprint and run it. Even though if you have functions of it, of interface, it's not like Blueprint that you see what's going on. Everything needs to be run through the code. So to check the result, mostly logically, actually, you need to run other function and other events. In this case, I have activate item, which is an event. Check and activate. Event again, give me a message, activate on by ID, give me an ID and hide item. So if I go to implementation of this, for the hidden, I will check hide item. If item visibility was true, I will call hide item. If it wasn't true, I will call hide item send false. Here we go. I can simplify this code to this. I just send to hide item, which is an event, the item visibility, which get received by pure C++ interface. So as you see, I don't have direct access to this PPI in Blueprint. I need to call a Blueprint event or function to send the result through that interface to the rest of my code, just to make it visible. If you don't have Blueprint wrapper, you can totally run this from C++. For the other one, I call this Blueprint event. For this one, I call this Blueprint event and send data. For this one, I just this Blueprint event send my ID. And for this one, I just return ID, which is basically used in different place perhaps. Anyway, and if I go to my Blueprint, here we go. This is my item activate. Oh, activate item, sorry, activate wait item, which is my C++ implement table event. Here we go. This guy. One thing in Blueprint. So if I make a custom event in Blueprint, I believe you already know, just a review, and I call it KO. So I can call this KO everywhere. From here, for example, I can copy, paste that to begin play. From begin play, I call this event like this. Just be organized. Here we go. And every time this event get called, I just print KO like that. So this is very luxury. This is Blueprint. You can make a custom event. You can populate that everywhere, and everywhere you can call it. If you have if you have a C++ implemented Blueprint implementable event, which is this guy here, you don't have the Blueprint luxury of events to call it anyway, anywhere. You can't. This event can only get activated from C++, which is located in parent class. This guy here. This one. So keep in mind, when you run pure interface of C++, you need functions or events that you can bring up into Blueprint if you need, and get the data from those interface from the C++ in the parent class in the background. And the rest of the story is exactly the same. Send and receive data and grab it from interface. Alrighty, let me check if I missed something here. Not just skipping my, yes, actually, yes. Now, from character, if I press F key, I will run pure C++ interface, how this part is working. So if I go to tracer, go to the last function, which is type D, same story, I figured out the line trace, grab the actor, and here we go. You need to include the C++ pure interface, which you already made, and header file of your object. Then you need to make an I name of your interface, pure C++ interface, in this case, CPPI item tools. You need to make a pointer out of it, a variable pointer. You need to cast the actor you try to access, you try to call the interface on it. You need to cast an interface pointer of the interface you like to call on that actor, which logically makes sense. This is my actor, and I already inherit this interface from this actor. So based on C++ programming rules, if you have parents of an object, if you cast to one of those parents, you will have a result. So you won't get a null pointer. You will get an interface, an instance of that interface, let's say. And here, if that thing is not null, means that interface exists. Then I activate item, I activate data, send value. I return a value out of that interface. Receive, let's say. This interface return me a if you move here, it shows an integer, virtual integer. And here we go, virtual integer. So this very simple, basic example of how you can do that. Again, please check the latest documentation for these guys here, casting, for the pure C++ interfaces, and also execute for Blueprint, C++ Blueprint implementable interface. Always check the latest documentation related to the version of the engine you plan to work with, and see if there is any changes, if there is any problem. Alrighty, so let me just run this one more time. Press F, and that works perfect. Pure C++ interface. If I press C and V, same story. All of them are get hiding by using C++ implementable interface, CPPI. So, homework. There is one item here which doesn't work with any interface. Totally nothing. And if I go to this function, to this object, I go to the parent class. As you see, I just have activation blueprint interface, which is from the previous video. So it's a good idea as a homework, let's say practice, not homework. You practice to implement blueprint, new blueprint implementable interface, perhaps add some light to it, and then practice to make a parent class of actor, make a C++, pure C++ interface, assign to that parent actor, and then assign to this object, and use a C++ pure interface on this object. Other practice can be change every interface here to pure C++ interface. You may need to put more functions, perhaps in this code, to receive key, perhaps, and perhaps change your C++ interfaces in this guy here. Alrighty. So that was basically the implementation interface with Unreal Engine by using C++. It's very important topic if you apply for serious job in industry, game programming or application programming with Unreal Engine, you must know interface. Interface exists in other programming languages like C#, like JavaScript, like Python. So using them is a power. You will save a lot of performance, a lot of optimization on your application, especially real-time application like games. When you work with virtual reality headsets, mobile phone, and system which are weak in process and memory. Interfaces access the parent class, and from the parent class, they can run the objects. So you don't need to have a reference to the actual object. All you need to do is just ask, do you have that interface? Like the good morning example at the previous video. Do you have that interface? Yes or no? If that interface exists, then you can send and receive data. It doesn't matter how big is that object. It doesn't matter how complex is that object. Interface programming are ideal for AI programming and multiplayer and real-time applications. You can send everything with one interface function or event, or you can separate, group your interfaces based on scenario or type of use. Or if you really need speed, it's good idea you just send one data or just send no data on calling an interface. These interface, for example, are ideal to running on tick. This one, not really. Perhaps you say, yes, Cliff, I use this and this and this, and all of them I'm using on tick. Well, think perhaps you can simplify this process. Perhaps part of this data can happen somewhere else, or part of this data doesn't need to get refreshed on each tick. Or you can separate that tick to different objects, just make it the load of the engine of all these data a little bit less. Yes, they are. This is not reference access. This is interface access. Makes sense pretty fast. But think about it. This is really art of object communication in Unreal Engine. Thank you very much. And have a beautiful time with programming.